week, we talked about when you, so we talked about changing our amplitude. That was the A, right? And so you can like stretch. We stretched our graphs, and I did show you one where if you have a negative A, right, it flips it like that. Okay, so that's what we did last week with our A. And then we also talked about shifting our B, which changes our period. So basically, it's like a vertical compression, essentially. If your B is normally 1, you can see one side of the graph. That's 1 period. And then if you make it into a 2, suddenly you have 2 periods on that one side of the graph. Does that kind of make sense? That's what we did last week. And honestly, I feel like last week the hardest part was like labeling your x-axes, which I think is still true today. So then now what we're going to talk about is, first we're going to talk about a vertical, like translation up or down. So that's our plus k. And so you can see if you add, so that's at 0. If you add 1, it shifts it up 1. You add 2, it would shift it up 2. If you subtract it, it would shift down. Okay, so that's going to be our vertical shift. And then the trickier shift is our horizontal shift. Let's see if I can actually make this work this time. Finer. Okay, so our trickier shift is when we're moving left or right, because it actually works backwards to what you think. So if you add 1, it's actually going to move to the left one. And I think most of the time we think right one, but whatever. But it's weird because we are working with like a wave. So sometimes the vertical shifts aren't going to look like they do anything, because it's just going to shift one of your periods over. But if you're graphing multiple periods anyways, you won't see that. Most of the time you'll see, like this was a sine function, you can see our y-axis or our y-intercept is totally different. Okay, so it does make it not fun in terms of labeling your x and y-axes. That's sort of a pain, but it's doable. So let's look at our notes. So this is like what the book gave for sort of like a breakdown of our different like transformations. So I guess if I'm just picking this apart, A affects our amplitude, and this would be like a stretch or a shrink. Stretch/shrink. B affected our periods. So like how many, like it was basically a vertical stretch or shrink, but we're just going to talk about the period. The H part, this will be our left or right. And then the K, which we'll squeeze in here, is going to be up or down. And if you can't squeeze all that in, that's okay, because we're going to rewrite these multiple times. So the book does kind of give you like a breakdown on how to graph these. I think, again, just as we go through the examples, you'll see the ways that make sense, just moving points. So I'm going to start with the up and down shift because that tends to be the easier one. And it's easier because we have this idea of a midline. So honestly, these two boxes are sort of the same. But a midline is when a constant, and normally the constant we use for an up or down translation is a K. So when a constant K is added, the graph shifts up or down. So when a constant K is added, the graph shifts up or down. Since we're working with a sine and a cosine, they're in this nice wave. We can think of, instead of moving like the whole graph, we can think of almost moving this midline or this x-axis. And then we just follow that. So we can say the new horizontal axis is the midline. So if you were given the function y equals a times sine of x plus k, y equals k is your midline. So is the midline. And I guess I don't know why they split them into two boxes like this, but we'll just do it. So basically, you're going to see the function either y equals a times sine of x plus k, or y equals a times, not sine, cosine. Cosine. A times cosine of x plus k. And the rule is if k is positive or greater than 0, up k units. I'll just say up k. If k is negative or less than 0, down k units or down k. So I'll just do like a really, really easy one right here. This is hard to see, but it is like our normal period where it's counting by pi over 2. So one period is 2 pi. Let's say this is counting by 0.5. So this goes up to positive 2, down to negative 2. If you were given the function y equals sine of x plus 1, actually, let me color code here. Let's do the plus 1 in pink. How much I like my colors. Plus 1. That plus 1 shifts your midline to be y equals 1. So basically, before I drew any dots, I would draw a new midline that goes here. My amplitude for this graph, my A is 1, meaning the height of the top of the wave is just 1. It's a sine function that we haven't shifted left or right, so it should have its intercept usually at 0, 0, but now it's going to be at 0, your midline, right, which is 0, 1. And then it starts up because it's positive, so it'd be here, to here, to here, to there. This one would be there, there, to there, to there. You guys remember how we did those points last week? And again, we're just going to look at sine and cosine today. We'll look at tangent tomorrow. But that is our sine graph just shifted up 1. Okay, so if you look at example 1, how we're going to run through these. So that that definition one I gave you had an A of 1 and a B of 1, right? But now let's look where our amplitude and our period are both affected. So example 1, we want to graph y equals 2 times sine of 4x plus 3. So a couple of things to look for. I still know that my A is 2 and my B is 4. But now this plus 3 over here, what does this plus 3 do to my graph? Moves it up 3. So I know I'm gonna go up 3, and I'll deal with that in a second here. But I still need to think about what my amplitude is. So my amplitude is 2. I'm just gonna abbreviate. I think we're all good now. Amplitude is 2, and my period. Now this is kind of just funny. Remember on Friday we were working with tangent, where the period was pi over your absolute value of b. We're back to working with sine and cosine. So remember, just in general, your period for sine and cosine is 2 pi over the absolute value of b. Okay, just don't mix those up because tangent was pi over b. We're back to 2 pi over b. So my period here would be 2 pi over 4, which reduces to pi over 2. If I need to get my intervals for what I count each thing by, I divide that by 4, which would give me pi over 8. Now let's deal with that plus 3. That is going to, so up 3 will make my midline be y equals 3. So I'm still going to label everything sort of the same. I need to get up to an amplitude of 2. So I think I counted by ones here. So 1, 2, 3, 4, 5, that's 6. 1, 2, that'd be -3. I'm counting by pi over 8. So this would be 1 pi over 8. This would be 2 pi over 8, which is pi over 4. 3 pi over 8. 4 4 pi over 8 ends up being pi over 2. That's going to be 1 full period. And then just for the sake of labeling, 5 pi over 8 would be my next one. Whoops. And then this would be negative pi over 8. So remember, that was kind of the tedious part of what we did last week. And then my midline, we now said is at y equals 3, so I'm going to draw a line here. That is somewhat straight. All right, this is the sine function. So it starts on the y-axis normally at the origin, but now it's going to be at the midline. So it'd be here. My amplitude is 2, meaning the top of my wave has to get up to 2. So I need to count up 1, 2. That'd be there. My next one, that's the top of my wave. So then my intercept would be here, then down 2, then back up 2 again. And then I guess this one would go down 2. Everyone still somewhat comfortable with graphing from last week? Again, we had specific rules for it, and you're welcome to use them. But I think this is honestly easier. Then my wave just looks like this. Tanya, you have a question? Oh. Are there any questions about our vertical translations? So again, if it was -3, we'd go down 3. And we hope that Mrs. Hopkins gives you a decent graph to do that with, because I did mess up on example 2, which we'll fix it in a minute. Okay, so vertical translations, the up and down, those tend to be the easier ones. Now let's look at our horizontal ones. So you might see them called phase shifts, but this is also a horizontal translation. And horizontal translations, I don't know if you guys have noticed with any kind of function, anything you put with the x is going to be a horizontal translation. So like when we did parabolas, when you guys were in vertex form, if it was like x plus 3 all squared plus 2 or something, that plus 3 inside would move you to the left 3. So it's operating the same way. You're going to have a function that looks like y equals, did I not put an a there? Sure. Should be an a times sine b of x plus h, or y equals a cosine b of x plus h. Sorry, squeezing. And then it works backwards to what you think. So if h is positive in here, that means it's actually going to be shifting left h. I guess I'm going to say shift. I'll move it left h. And if your h is negative or less than 0, it's going to move right h. I won't draw an example here because we're about to do one, which I do have to fix because I did mess it up. Okay, so example 2, I messed up because I gave us exactly 3 periods and I actually needed like 1 more. So if you can just cross off the 3 in front of the pi, make it a 1 pi. We're just going to shift pi over because then I have enough. And then, yeah, no, that's good. Okay, so just make it a pi. So that minus pi, how does that shift this graph? To the what? To the right pi units. Okay, but when I graph this, I'm still going to name my a. So my a is 5 and my b is 2. So this means my amplitude is 5. Since I'm not shifting up or down, I can go ahead and label my axes. I need to get up to 5 and down to, I made a mistake where I didn't give you enough down to 5. So we have to count by 2s. Sorry. So 2, 4, 6, 8, 10, 12, because then I only gave you enough space for -6 here. Sorry, my bad. So my amplitude is 5. So we're counting by 2s on my y-axis. My period is going to be 2 pi over 2. So my period is just pi. And if I split this into my intervals, it's going to be pi over 4. So that means this would be pi over 4. This would be 2 pi over 4, which is pi over 2. 3 pi over 4. This would be 4 pi over 4, which is pi. So that'd be 1 full period. And then if I wanted to keep counting, that'd be another period. That's 2 pi. And in between, let's see here, that'd be 5 pi over 4. 6 pi over 4 reduces to 3 pi over 2. 7 pi over 4. I swear the hardest part about these is just counting fractions. This would be 9 pi over 4. This would be 10 pi over 4, which reduces to 5 pi over 2. This would be 11 pi over 4. Squeezing that all in. And just for the record, this would be negative pi over 4. Okay, I'm only going to graph one period, only because this one, the way we shift this one, it actually just shifts to the next period. And I'll show you what I mean by that. So this is a cosine function. So where does cosine normally start?
0, 1.
0, 1. So normally it starts at 0 in the amplitude. My amplitude is 5 here. So I'm actually going to start it here. And I just want to put points for one period. So I'm not going to connect these. So it starts up and then it would go down to my x-axis. And then the next point over would go down to a minimum. And then I'd go back up to my x-axis and then back up to a maximum. So this is one full period. And again, I haven't really asked you to like graph just one period or anything like that, but this is one period. And now if I want to move it to the right pi, that means I'm going to take every single point and I'm going to move it over. I know that pi is one period, so I'm going to move it over 4 spaces. Does that make sense?
Yeah.
Okay, so this point here is going to move over to this point. And now the nice thing about this, well, nice or not nice, the nice thing / not nice thing about this one is it actually translates right to the next point here. This one would move over 1, 2, 3, 4. This one would move over 1, 2, 3, 4. And this one would move over 1, 2, 3, 4. And then this guy, 1, 2, 3, 4. So you can see my translated function, if I'm just graphing one period, would look like this. Now, I do want us to graph more than one period, but I just want to show you how that just moved it over. So I actually do still have, like, if I continued with this pattern, it's still going to be like the normal cosine wave, and that doesn't always happen. And unless I specify otherwise, you could just graph the whole thing. But I wanted to show you how in this particular example, I didn't go low enough here. Sorry. I'm just going to 4. There we go. Does that make sense with that one? It's a weird example that I chose to do. Thanks, book. The book suggested it. Let's do another one that has better shifts where it's more trippy. Are there questions about that one, though? Kind of weird. Let's look at a trickier one where it doesn't shift us to the specific point that's already there. Oh, and let's also talk about reflections. So they have this lovely definition of reflections. I thought just drawing a picture is clearer. And we can draw really quickly. You guys can draw the parent sine and cosine. You should be pretty quick with it now. So if I just gave you 2 axes like this, and I wanted one period of each, this would be pi over 2, pi, 3 pi over 2, 2 pi. I'm not even going to label everything. Go like that, and then that's at +1, at -1, -1. That's our like traditional setup, and of course I made them not look the same. So what we saw last week, our parent function, if it was y equals sine of x, it starts here to there, to there, to there, to there. That's one full period. Right? By that? Didn't mess that up? So if you have the negative, then it'd be y equals negative sine of x. And that's just going to flip points, but it's going to flip over the x-axis, so nothing happens to your intercepts. And basically your maximum and minimums switch. We have sort of like a double helix thing going here. So that would be your sine, and your cosine is going to look the same, but like if you shift this over, so y equals cosine of x starts up at your amplitude, and then goes down there, to there, to there, to there. That's one full period. So if I just made this a negative, this would just switch. So I can give you all the fancy definitions in the world, but I think this picture says enough. That's what we're doing for negative and positive, or the reflection over our y-axis, or x-axis, excuse me. And I think there was one of them on your worksheet from last week that did that. One of the ones on the front page, I think number 4. Any questions about reflection? Okay. Oh, yeah. So example 3 is going to be the trickiest one because it has 2 transformations. I think on one of your worksheet problems, I give you even 3 transformations. I do a flip, a left or right, and an up or down. That's as many as I can give you. Then I guess a stretch, but. So for example 3, am I good now, time? Example 3 here. I'm just going to like circle what transformations we have. We do have a negative here. And we have this plus pi over 2. So what is the negative going to do? Flip, reflect, whatever fancy word you want. I'm going to say reflect. And for the record, it's reflecting over the x-axis. There is a way to reflect over the y-axis, but we're not going to do that. And then what does the plus pi over 2 do? To the left, pi over 2. But then I'm going to sort of treat this like it's what we did last week. So I'm going to say, okay, my A here is 2, and my B is 2/3. So since my A is 2, my amplitude is 2. I don't have a shift up or down, so I'm going to go ahead and graph my y-axis. I can just count by ones here. So I can go up to +3, down to -3. My period, this is a little funny. So this one would be 2 pi divided by 2/3 is the same as multiplying by 3/2. Is by that. So the 2's would cancel out and I'd have 3 pi. So the weird part here is now my interval would end up being 3 pi over 4 or 3/4. And I'm shifting it by pi over 2. So now you're going to see that it's not like lining up necessarily on these like tick marks. So we have to think more about our fractions. So before I do that, though, I'm just going to label it like there is no left movement here. I'm just going to label it with these intervals. So this would be 3 pi over 4. This would be 6 pi over 4, which reduces to 3 pi over 2. This would be 9 pi over 4. And then this would be 12 pi over 4, which reduces to 3 pi. That's one full period. This would be 15 pi over 4. And then this one would be 18 pi over 4, which reduces to 9 pi over 2. And I'm not going to worry about that one. Then I'll do my negatives. This would be -3 pi over 2. And this will be, no, over 4, sorry. -3 pi over 4. And this is -3 pi over 2. Okay, so before I do anything, I'm going to plot my points. This is a sine function, so it starts at the origin. And then it's negative. So instead of, I would normally go to a maximum, now I'm going to go to a minimum. So this will go down to -2, because that's my amplitude. then back to my x-axis, then up to my maximum, back to my x-axis, down to my minimum, x-axis, up to maximum. This way it would have gone up to a maximum, down to my x-axis, down to a minimum. So those are my original points. Now, how do we deal with this left? So the mathematical way, if you're going left pi over 2, you're going to subtract, subtract pi over 2 from each point. So when I was making this, I was like, okay, well, that's kind of tricky. What I think of instead of is like, if you started with this one here, just to see how you need to move each time, 3 pi over 4 minus pi over 2. Heck, if you want to ignore the pi's for a second, you can just think of it as 3/4 minus 1/2. What would 3/4 minus 1/2 be? 1/4. So if I think of this as 3/4, this is almost moving it like 2/3 in this direction. So I'm going to take every single point here and I'm going to move it 2/3 over. So it's almost like at 1/3 of that. Does that kind of make sense? So I'm going to take every single purple point that I plotted and just move it over. So this one goes over there. This one goes here. This one goes here. That one I moved over. This one goes here. It's to the left because it's a positive. You have to move backwards. It's not really 2/3, but this is 3/4 here. So this would be like 1/4, 2/4, 3/4. Right? This is like the one. This is the 1/4. This would be like a 1/2. 3/4, 1 is there. 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 That go there. So yeah, I mean, this is like thinking about your fractions and how you're moving because it's not necessarily going to line up on your nice tick marks. But it doesn't have to be perfect here. So this would be like that. So the left and right shift, not as much fun because it's a little unclear where things are. Notice our like y-intercept doesn't have much meaning anymore. It's not like at a nice point. That's fine. Okay, so we're gonna practice with these tomorrow.